So in the last unit 6.1, we have seen that what are the different kinds of bearings, what are the different types of bearings, how the roller bearing and our ball bearing differs, what is the difference between these two, as well as advantages of sliding contact bearing over the rolling contact bearing, disadvantages of sliding and rolling contact bearing, its application that we have seen in the first unit. Now in this unit, we are going to see about the terminologies in the anti-friction bearing, as well as we are going to see the how to select the bearing from bearing catalog. So in front of you, there is a simple figure. So it is a figure of ball bearing. You will find that there is a radial load and axial load acting on the bearing. So if you just see the different parts of the bearing, the exploded view is shown here. The balls are kept inside the cage and there is inner and outer racing. So inner diameter is the bore diameter, width and outside diameter is shown. The rotating element, ball or roller, is fitted inside the cage. So this is a simple construction of our roller or ball bearing. As far as loading is concerned, radial load and axial load that directly given on the roller or ball. When the ball is subjected to such type of load, ball is a rotating rolling element. So the ball, when exactly at the bottom side, then it's subjected to high compressive load. When again it rotate and it come at the upper side, the load is get released. That means there is a compression release type of loading happen on the ball or roller. Because of such type of loading, obviously when such type of repeated loading is on any component, it is subjected to cracks, and that crack is formed, and that property we called it as a fatigue property. So the main failure criteria of this bearing is fatigue failure. Okay, so fatigue failure means when the machine component is subjected to repeated type of stresses, it fails before the yield point. So in our theory, we know that there is endurance strength. So that endurance strength is the fatigue strength. How many individual bearing that complete a particular life is important. So the life of individual bearing is defined here. It is the life as the number of revolutions which the bearing runs before the first evidence of fatigue develop in the material of the ring or any of the rolling element. So that means if the bearing is subjected to radial or axial load, as it is a rotating part, after some period of rotation, so obviously that rotations in million revolutions. After million revolution, there is a crack. The first crack developed is the failure. So how many revolutions that bearing complete without failure is the life of bearing. So we can measure that in hours also. If there is a constant speed, then how many hours are required to fail that bearing, or the first evidence of the crack is the life of bearing. Now here you can see radial load is the load acting perpendicular, axial load is the load acting aligned with the axis of rotation. So when the bearing is at the static position. So obviously it is subjected to static radial load or axial load, and because of that, there is a compression of the ball or roller. The compression, if it within the limit, that compression when it is 0.0001 times the ball diameter, then that loading is the basic static load rating. So in front of you there is a definition. It is defined as the static radial load or axial load, which correspond to total permanent deformation of the ball at the most heavily stressed contact equal to 0.0001 times the ball diameter. When if the permanent deformation exceeds beyond that, then that is that is the limit of basic static load rating. C0 is the limit when there is a 0.0001 times ball diameter permanent deformation. Okay, it is in static rating. Now, if I combine this, then static equivalent load, F0. Static equivalent load is the combined static radial or axial load, which if applied would cause the same per total permanent deformation at the most heavily stressed ball or wrist contact as, as that which occur under the actual condition of loading. So, when there is a static and radial combined load, then if it having it happens with the 0.001 times of the permanent deformation, so that is called as a static equivalent load. Static equivalent load is the combination of radial load and axial load combined. Okay, so this is very simple terminologies, C0 and F0. Now just like static, there is a basic dynamic load. The basic dynamic load is the dynamic load condition, that means it is in the working condition. So it is defined as the constant stationary radial load or axial load which a group of identical bearing with a stationary outer race can endure for the rated life of 1 million revolutions. Okay, so what is that? So that is the load which is taken by the radial load or axial load on the bearing, which can complete 1 million revolution without failure. Okay, so that can be dynamic loading condition. So if the particular bearing particular bearing will take, or the group of bearing will take 1 million revolution of the life, then that is the dynamic load rating of the bearing. So dynamic equivalent load is the again, it is again combinedly, if the radial and axial load combinedly taken by the bearing when there is a rated life of 1 million revolution is taken under the actual load condition, then that is called dynamic equivalent load. Dynamic equivalent load takes care of radial as well as axial load combined. Okay. So in that, one term is there. What is the rating life? Okay. In that rating life of 1 million revolution, what is in the rating life? The rating life is nothing but it is defined as number of revolution that 90% of the group of bearing will complete without failure. So if I take 10 bearings and if I load it by axial and radial load, and 9 bearings complete 1 million revolution or rated any rated life, that means only 10%, means out of 10, if one bearing is failed, then we can say that that hours of life or that much revolution is the rating life of 10 bearings. Okay. So the minimum life is the rating life which the 50% of the group of bearing will complete or exceed in approximately 5 times the life which 90% of the bearing complete or exceed. So if the 5 times of 90% bearing will complete by the 50% of the group of bearing, that is minimum life of the bearing. So that means here the number of revolution completed by the bearing is very important. The bearing life is taken by actual practical approach, because here we have to think about the practically how many bearings complete, how many percent of life is very important. So failure of only 10%, failure of only 10% is important. If 10% of the bearing fail, then we said that that is the rated life for that particular speed and for the particular load. Okay. So here, by using this C0, that is static load, C dynamic load, or equivalent load F, we have to select the bearing from the catalog. Okay. So that is one more part in our syllabus. What is the how to select bearing from manufacturer catalog? So as we know here, very less calculations are required. We know only the radial and axial force, nothing more than that. Okay. So we know some of the factors, such like radial or thrust load factors. Okay. This much is the known thing here. So that's why in our bearing we need not go for much more complicated calculation, just like in our other machine components. Here, important thing is how to select the bearing from catalog. Standard bearings are manufactured. Only we have to select. The selection of bearing is important. Okay. For that, so this is the steps. This is the steps in front of you that are important, which are used to select the bearing for manufacture catalog. So flowchart is given. Now this is the question which is many times asked in our exam, and which gives you 6 to 8 marks. The first step is calculate radial and axial load. So we know that every bearing is subjected to radial and or axial load. There may be possibility that the bearing may subjected to only radial or only axial or combined. After that, we have to select from that FR and FA value a bearing from the catalog. Okay. Now find the static capacity from the catalog. Okay. So select proper bearing from the catalog means what? Say if there is the bearing is subjected to only radial load, so you should not select roller bearing. When the roller bearing is applicable, if taper roller bearing or roller bearing can sustain radial as well as axial load. If there is no axial load, then you can select simple ball bearing. Don't go for radial or sorry, roller or taper roller. If the load is not that much high, so why should we go for roller? So we can select ball. So such type of thing we have to select when we go for a bearing selection. Once you select the bearing, we can find the basic static capacity, basic dynamic capacity from the catalog. Now, once we know that basic capacity, we can find FA by V into FR, FA by CO ratio, because these ratios are important to find the other factors. So after that, calculate the radial and thrust load factor from the catalog. Find the value of load factor from the catalog. So whatever load factors, everything that we have to select from the catalog. I will show the catalog also. Calculate the equivalent dynamic load from the FA and FR. You have to go for X value and Y value, which are the radial and thrust load factor from the catalog, which are based on the FA by V into FR and FA by C0 ratios. So From that, you find the equivalent dynamic load. Select the expected life, how much life is expected. After that, calculate the required basic dynamic capacity. Now, if it is a ball bearing, then the factor is A is equal to 3. If it is not ball bearing, that is roller bearing, A is equal to 10 by 3. From that, required dynamic capacity. There is a required dynamic capacity formula is also given. So from that, the required dynamic capacity that we can find. Now, if that required dynamic capacity is less than our whatever we got from that particular radial and axial load, so that is our simple dynamic basic dynamic load. If that basic dynamic load is less than the required dynamic capacity, then the particular bearing will sustain that much load. If that is not, if the critical required dynamic capacity is greater than the whatever basic dynamic capacity, we have to again repeat and we have to take another type of bearing and we have to find again some C0 and C from the catalog. Okay, so this is the very simple steps. From this simple step, we can find suitable bearing from the catalog. Okay, so how this catalog can be? So in front of you there is a standard catalog. So there is a single row deep groove ball bearing catalog. You'll find that there is a principal dimensions like diameter of the shaft, bore diameter, outer diameter, width of the bearing, basic load rating, dynamic and static, fatigue load, speed rating, limiting speed. Okay, from this you can select the designated bearing. You can find that here there is a 6202 dash 2Z. So this is the first designation of single row deep groove ball bearing. This is the example. So by this way, for the particular basic load, for the particular dynamic load, you can select the proper bearing from the catalog. So this is the very introductory part that we have in our syllabus. So that finishes our simple steps how to select bearing from bearing catalog.